To start reviewing all these exams that we've taken in class, so let's jump in and get started. Some of these answers are going to be straightforward, and others are going to require a little bit of work. So there are certain things that you just have to memorize, and I want to make sure that we just get through those quickly. So, for example, question number 1, a vector is a quantity that has both magnitude and direction. That's just something you're expected to memorize and just kind of know instantly. So we're just going to circle choice C right there. Now, which of the following is a scalar? Velocity is not. Or sorry, which of the following is a vector? Time's not, distance not, speed's not, velocity is. So you're just expected to know that. Okay. Which of the following describes the displacement of an object? So let's remember, displacement is written as delta x in exam 1, and that's x final minus x initial. So you're expected to have that known, and so I'm going to look at the thing that actually has this described, which is choice D, change in an object's position. Now here. A person runs around a track 4 complete laps around the track. So what I'm going to do is I'm actually going to use the answer to number 3 to guide me through the answer to number 4. So here, I go around a track, so I'll just call this point P where I start at. So delta x is x final minus x initial. So I start here at this point P, and I also end at that point P, so what that means is my final and my initial, they're the same. And because they're the same, when I subtract them, I'm going to get 0. And moving on. Here we have 2 very different objects, and I decided to clarify here. I said, which object has the largest velocity? Technically speaking, the word here should be speed. And the reason is that velocity implies direction. Velocity implies direction. So we have to be careful about that. Implies direction. So which of the objects is traveling fastest? That would be object E. Just reading the number. Again, it's absolute value that we care about when we talk about speed. Okay? So in one dimension, remember that speed is the absolute value of velocity, like that. Okay? Now here, the next few questions refer to a position versus time graph for a person on Ellis Street. The reference point is considered entry to the Student Life Center. East is towards downtown and considered positive. So, in other words, we have a y, or we have a position versus time graph that's x versus t, but let's be clear. When we talk about positive and negative here, this axis would be the east axis, and this axis would be the west axis, or this direction would be the west direction. So I'm going to use all of that to guide me. So look, I start here going east, and I go further and further east in number 6, and I'm doing it at a constant rate. I know this because my curve is not sloping in any way, it's just a straight line, okay? Meaning it has a positive slope, but it's not curving, say, like this. This would be non-constant velocity. So with that in mind, what this means is that if here's the door and I start here, I'm actually starting east of the door, so that rules out this, and this, and this. I walk east at constant velocity. That gives me choice C. Alright, now moving on to number 7. What is the person doing in this position versus time graph? Well, I'm still walking in the positive direction, and I know that because my slope is positive. So positive slope means moving in the positive direction. And in this case, when we go to the previous page, and we look, east is considered the positive direction. So I need a choice that tells me I'm moving east. So that rules out B, that rules out D, that rules out E. Now, do I start east of the door or west of the door? Let's actually look at my starting point. Okay, so when I look at my starting point that's down here, clearly if this is west and this is east, and again, keeping in mind this is position versus time, and the positive direction is east and negative is west, I'm starting west. So that gives me choice A as my answer. Now, what's the person doing in this graph? Again, the hint here. When you see a flat line on a position versus time graph, not a velocity graph, a position versus time graph. That means you are standing still. And where are we? Let's look at the picture. Once again, we're west. So we need a standing still choice. That rules out B, C, and D. And again, it leaves us with choice A. Right? Now, number 9, what's happening in this position time graph? Let's remember, if we have a graph and we have 2 objects, let's say a blue object and a red object, okay? Let's keep in mind, in this case, the blue and the red, let's just compare. Blue is, and this is position versus time, blue is faster than red because the slope is steeper. This goes back to the buggy lab. So blue is faster than red because the slope is steeper. So in this case, when we look at this, we see that, both are walking at constant velocity. They're walking in the same direction, so that rules out E. They're not walking east, they're walking west. And of course, we see that A has the steeper slope, so that means choice A. A is walking faster. Now, here. We have B. Notice its slope is negative. That means it's walking backwards. And that implies it's moving in a west direction. Okay? So they're not both walking west. They're not both walking west. One is walking west because A is walking east. That rules out this. That rules out this. And of course we know that they are walking in opposite directions. The reason we know that they're approximately at the same speed is that they have the same steepness in their slope. Now, what happens at this point P here for number 11? What happens at this point P is they're passing each other at the entry to the Student Life Center in this problem. Now, Now number 12. Suppose we want to do the position versus time for someone starting. For someone starting at the entry of the Student Life Center and walking west, well, that means the person would actually have to walk backwards or walk in a negative direction. So let's find the graph that shows that. And that graph happens to be this one right here. Because I start at the Student Life Center and I'm going further and further in the negative direction, which is west. Somebody standing still west to the entry. We have actually, remember this is the axis, so that means that choice D is the possible answer. Now, if they're walking in the same direction at the same speed, let's be clear on this. That means, 2 ways to look at this. They should have the same slope on the line on their position versus time graph. And the one choice that shows me that is this one right here, choice B. So in other words, a hint is parallel lines. Now, we've moved on to the free response section. So let me just check and see how much time I have. So I'll get started on this, and maybe we'll finish it in the second video. So we have a position versus time graph, and let's just get a couple things out of the way. First, I just want to look at this graph and just identify a couple things first. Notice my initial position here is 10 meters, and I'm moving at a constant rate. So it says, what is the velocity of the object? To get the velocity of an object from a position versus time graph, this takes us back to the buggy lab. Let's get the slope. So that is going to be, now the slope formula traditionally is y2 minus y1 over x2 minus x1. But let's remember, we're not doing algebra. So I know you can write it this way, but I personally am not going to use this formula. I'm going to write that the velocity is the change in position versus the change in time. And what I want to do is I want to find a time and a position where I can clearly read it from the graph. So when I go up here, I see that I'm at 80 meters at 10 seconds and 10 meters at 0 seconds. So look what so this is 10 seconds and at 80 and 0. So I'm doing this a little bit quickly because you are expected to be absolutely 100% fluent in Algebra 1 in this class. So I should be able to do this quickly and you should be able to understand the answer. Okay, so we have 80 minus 10 divided by 10 minus 0. And when I do that, that's going to end up giving me a velocity of 7 meters per second on this problem. Now it says, what is the object's position at 10 seconds? I read that from the graph. At 10 seconds, I'm clearly at 80 meters. Now, what is the displacement of the object? Let's again be careful. Displacement, delta x, is x final minus x initial. So that ends up being 80 meters minus 10 meters, my initial. I read it off the graph, and I end up getting 70 meters of displacement. Okay. So that's actually a good place to stop for now, and I will take up the rest of the exam in our second video.